Alrighty, here we go. Section 3.1, Chapter 3 talks about inequalities. So 3.1 talks about inequalities in their graphs. After this lesson, I want to be able to write, graph, and identify solutions to inequalities. So, here's my essential understanding. An inequality is a mathematical sentence that uses an inequality symbol to compare the values of two expressions. You can use a number line to visually represent the values that satisfy an inequality. Before, we talked about equations, which use equal signs. All right, now we're talking about inequalities. So perhaps you've seen some of these before. Expressions such as less than or greater than. So there's symbols that go along with those things. So, excuse me. So less than gets one of these symbols. It goes the same way as an L. An L goes like that. This opens the same way as an L. Less than. When I go to plot it on a number line, I would use an open circle or an open boundary point. It would look like that. You'll see more of that here in a second. It might make a little more sense. The next one would be less than or equal to. So a number can be less than or equal to another number. Symbol looks very similar to this, except when you have an equal to, I have to satisfy that also. Less than or equal to, I put one of the lines of an equal sign underneath it. Less than or equal to. Anytime I have an equal to, I'm going to get a closed boundary point, a closed circle, which would look something like that on my number line. Greater than. Well, if less than goes this way, well then greater than goes the other way. So greater than looks like that. Again, an open circle because there's no equal sign. It looks something like that. Greater than or equal to. Well, now I'm back to that equal to thing. Greater than, or equal. So it looks like that. Closed circle because of the equal sign. Fill in the dot. All right. So here we go. So we have a verbal expression. All real numbers, x, less than or equal to -1. Less than or equal. So when I go to write this thing, any number, x, less than or equal. So I got to remember what these symbols are. That's why I have them written on my sheet. So use your sheet so you get it right. Less than or equal to -1. When I look at the picture, all the numbers that are smaller than, less than, or equal to -1. So it has an equal sign. Okay? So it could be equal to -1. It could also be smaller than -1, like -2 is smaller than -1. -4 is also smaller than -1. So these points work. Those are solutions. -5 is less than -1. -10 or whatever number's further to the left is also less than -1. -2.5, so it doesn't have to be a whole number. It could be an integer or a decimal. And -1 is also less than or equal, because it could be less than or equal to -1. Now other numbers like 0 is not less than or equal to -1, so that does not work. 2 does not work. Okay? So instead of putting a whole bunch of points here, because every single number here to the left of -1 works, including -1, every point over here works. Fractions, decimals, all these numbers. So normally what we do is we just put a dot for the boundary point that separates good points from bad points, and then we just shade it. So I'm going to shade everything to the left, less than. All numbers left of or equal, that's why it's filled in, to -1. Okay, it's less than, left of. All right, here we go. All numbers greater than 2. Greater than 2. So go back to your symbols on the little chart in the front. So greater than 2. X is greater than 2. All right, some numbers that work. Well, 4 is greater than 2. So I would fill that dot in. 2.5 is greater than 2. So I would fill that in. 5 is greater than 2. Those are all good points. Those are all solutions. 3 works. But -1 does not work. So I don't want to fill that in. 1 does not work. 2 does not work either. All right, but 2 separates the good points from the bad points. 2 is not greater than or equal to 2. 2 is not greater than 2. So he's got to be an open circle. Remember the little chart from the beginning. So on the boundary point, the thing that makes the left side and the right side exactly equal, I'm either going to be shaded or open. With no equal sign, I'm going to be open. And now I just got a shade. Well, greater goes to the right. So notice where all the points are that work. They're to the right of the boundary point. So an open circle on 2, everything to the right gets shaded. It would look like that. All right, let's continue. Here we go. Here's an inequality. N less than 2. N is less than 2. Just know what this symbol is. How do I know that? I memorize it. Less than. It goes the same way as an L. N is less than 2. All numbers less than 2. Or you could just write N is less than 2. N represents all the numbers that work. Okay? Could be an X is less than 2. All the numbers that work. All numbers less than 2. Well, what's less than 2? Well, 0 is less than 2. Negative 3 is less than 2. Negative 4 is less than 2. 3 is not less than 2, so he does not work. 4 does not work. 2 does not work, but he separates the good points from the bad points. We call him the boundary point. 2 is where the left and the right are exactly equal. 2 is not less than 2, but that's where they're equal. No equal sign underneath here, so it's an open circle. All the points that work are to the left. It's less than to the left. Bang, it looks like that. Open circle, shade to the left. Okay? Ideally, you don't have to make this top picture soon. You just make the bottom picture. Open circle, shade to the left. All the points that are less than 2. All the numbers less than 2. All right, here we go. They give me another inequality. A, greater than or equal to 0. There's an equal sign there. So I know I'm going to have a shaded in circle on the boundary. All the numbers greater than or equal to 0. They could be greater than or they could be equal. So let's think of some numbers that work. Well, 0, shaded in, right? Because 0 works. He's also the boundary where the left and the right are exactly the same. So he's shaded in, equal sign, shaded, bang. Numbers that are bigger than 0 go to the right. 2 works, 3 works, 4 works. 3 is greater than 0. He works, so he gets shaded. Everything to the left does not work, so they do not get shaded. Everything to the right shaded because it's greater than. Here's another one. Negative 2, greater than or equal to x. All right, so what's that look like? Negative 2, all right, is greater than, so I need to think of what that symbol means. Or equal, so I got a little line underneath, to x. So there's my symbol. Negative 2 is greater than or equal to x. This part should be easy, especially if we do a little chart. Remember what greater than looks like. Looks like that. Equal. Put a little line underneath it. Bang. All right, now let's find some numbers that work. Well, if you put in negative 3 here, is negative 2 greater than negative 3? Yes, he works. So fill it in. Is negative 2 greater than or equal to negative 2? Yes, he works. He's also the boundary. He's where they're the same. All right, but notice the equal sign, so he worked. Negative 5. Negative 2 is greater than negative 5, so it worked. What about some other numbers, like 0? Well, negative 2 is not greater than 0, so it doesn't work. Negative 2 is not greater than 4, so it doesn't work. So numbers I'm putting in here for x, if they work, fill them in. If they don't, well, don't fill them in. Pretty simple. All right, the boundaries where the left and the right are the same. The boundary's at negative 2. Bang. Fill it in because of the equal sign. What does it say? Negative 2 is more than my numbers. Negative 2 is more than my shading. So all the numbers I'm going to shade, my numbers, have to be smaller than negative 2. If you look at the picture up here, all the numbers that worked were left of less than negative 2. All right? Gets a little confusing when they write it in this form. But if you just think about putting numbers in there to see what works, life's pretty easy. You might want to take the whole thing and flip it around, reflect it. So it might be easier to say x is less than or equal to negative 2. If negative 2 is greater than or equal to x, then x is less than or equal to negative 2. Maybe that's easier to see, because now you can see, ooh, all my numbers are left of, less than, or filled in to negative 2. Bang. to the left. All right? What they give me now? 2 less than a number k is greater than 1. All right, this gets a little more complicated. 2 less than a number. Notice it doesn't say 2 is less than. So 2 less than a number. K minus 2. Not 2 minus k. K minus 2. 2 less than a number. K minus 2. Is greater than. Is greater than. Greater than 1. No equal sign. Open circle. All right? So now let's think of some numbers that work. Well, if you plug in 0, is 0 minus 2 greater than 1? Well, that would make me negative 2. Is that greater than 1? No, didn't work. So that's not a solution. If you take 2 and plug it in, well, is 2 minus 2 0 greater than 1? No, he didn't work. So don't fill him in. I'm finding numbers that work. 3. Let's try 3. 3 minus 2. Well, that's 1. Ooh. But 1's not greater than 1. But that is the boundary. Notice that's where the left and the right are the same. So that's the boundary. Okay? So when I look at my final product, I'm going to have an open circle on that 3. All right, what else works? Well, 4. 4 minus 2 is 2. That is greater than 1. So that works. So if you look at your boundary 3, the numbers to the right of it worked. The numbers to the left of it didn't work. So shade to the right. Bang, easy enough. Notice even decimals, fractions, they worked over here. 3.1 minus 2 is 1.1. That is greater than 1, so he worked. He's to the right of the boundary, so shade him in. Number 7, the sum of t and 3. Well, what does sum mean? Plus. T plus 3 is less than. T plus 3 is less than 2. Okay? Cool, here we go. Let's find some numbers that work. Try 0. I always use 0 first. 0 plus 3. Well, that's 3. Is 3 less than 2? No, he didn't work. Pick another number. 2. All right, so if t was 2, did it work? Well, 2 plus 3 is 5. 5 is not less than 2. He did not work. All right, find me a number that works. Try negative 1. Is negative 1 plus 3 less than 2? Well, no, 2 is not less than 2. But notice they're equal. That's the boundary. That's the boundary. So negative 1 doesn't work, but he is the boundary. So on my final product, there's my circle. Notice it's open because there's no equal sign. Open circle. Now look, the points to the right of the boundary did not work. So I'll guarantee the points to the left do work. So let's find a point to the left, like negative 2. Negative 2 is over here. He's to the left of the boundary. Negative 2 plus 3 is 1. 1 is less than 2. It worked. Bang. So he worked. What else we got? Negative 5. He's left of the boundary. Look, he worked. So I'd shade to the left of the boundary. Once you find a point to the left that works, shade to the left. Number 8, they give you the picture. Well, what is it? It's filled in. So that's got an equal sign in it. Negative 1 is the boundary. So they shaded the shaded stuff. X is greater than or equal to the point. X is greater than or equal to negative 1. There's your boundary, negative 1. Notice it's shaded in, so it's got to have an equal sign. All the numbers, the colored in numbers, that's really what this means. The shaded in numbers, the numbers that work are greater than or equal to negative 1. All the numbers that are filled in are more than or the same as negative 1. All numbers greater than or equal to negative 1. Okay? All right, look at this picture. Boundaries at negative 2. Shaded to the left. Open boundary. No equal sign. So all the numbers shaded are left of or less than negative 2. No equal sign because it's not shaded in. X, all the numbers, is less than negative 2. All numbers less than negative 2. All right, here we go. 10. What do we got here in 10? All right, they gave me this inequality. 2 less than or equal to x. 2 is less than or equal to x. Okay, well, try a number. Try numbers for x. So put in 0. Did it work? Well, is 2 less than or equal to 0? 2 is not less than 0, so it did not work. Is 2 less than 1? No. So 1 did not work. Find a point that works. Is 2 less than 2? Well, notice it says less than or equal to 2, so it worked. That's also the boundary. That's where the left and the right are the same. So this is a good point right here. He's going to separate good points from bad points. He's the boundary. Notice to the left it did not work, so the points to the right will work. So I got a closed circle on 2. Numbers to the right, there's a test point for you. So something to the right, like 3. Notice it works. 2 is less than 3. So it worked. So I would shade to the right. Alright? It might help you to flip this thing around. I like to have my x on the left. So I just reflect this whole thing. If 2 is less than or equal to x, that means that x is greater than or equal to 2. X is greater than or equal to 2. I just turn the whole thing around. X is greater than or equal to 2. Alright, what do I got here? 0 less than C. 0 less than C. 0 is less than my numbers. 0 is less than C. Okay, cool. Well, 0 is less than 0? No, because there's no equal sign here. But it is the boundary. So he didn't work, but he would be the boundary when I make my final picture. Okay, let's find numbers that work. Well, is 0 less than 1? Yep. So that means 1 worked. What else works? Is 0 less than 0.01 or 0.00000001? So slightly to the right over here? Yeah. So he would work. Is 0 less than -3? No. So he's to the left. He didn't work. So if points to the right of the boundary work, that means points to the left of the boundary won't work. So everything to the right of the boundary worked. So I shaded everything to the right. Again, it might help you to flip this thing around. Reflect the whole thing around. If 0 is less than C, that means C is greater than 0. C is greater than 0. Okay? A solution to an inequality is any number that makes the inequality true. Just like the solution to an equation. Things that work, things that make it true. For example, the solutions of the inequality x is less than 5 are all numbers that are smaller than 5. Anything that works. 4, 3, -10, -8 million. Those are all solutions. They're all less than 5. We can evaluate an expression to determine whether a value is a solution. So here we go. Is it a solution? They gave me 2 choices. I got to test each one. So I just plug in -3 for x, and I see if it works. Well, if you plug in -3, 2 times -3 plus 1, is that greater than 3? Well, 2 times -3 is -6. Plus 1, is that greater than 3? Simplify to left. That's -5. Is that greater than 3? Is this true? No, that's false. -5 isn't greater than 3. That's a false statement. So -3 is not a solution. Let's try this one. Plug in -1 right there. Bang. So 2 times -1 plus 1. Is that greater than 3? This gives me -2 plus 1. That's -1. Is that greater than 3? No, -1 is not greater than 3. So it didn't work. Not a solution. Okay? Easy. Easy. Plug it in. See if it works. All right. What do I got? 13 minus 7y greater than 6. Plug it in. 1. If I plug in 1. 13 minus 7 times 1. Is that greater than 6? 13 minus 7. Is that greater than 6? Well, that's 6. Is 6 greater than 6? It is not. So it is not a solution. Notice if this was greater than or equal, it would work. But it's not. So it doesn't work. 6 is not greater than 6. Didn't work. Not true. 1 is not a solution. Take -1. Plug it in. -7 times -1. -7 times -1 is positive 7. 13 plus 7. Is that greater than 6? Sure is. 13 plus 7 is 20. 20 is greater than 6. So that means that it worked. So -1, this is incorrect. -1 is a solution. -1. That's what they were asking me to test. -1 is a solution. So make sure that you don't read that. Make that -1 is a solution. All right, last part. Write an inequality. School parking lot speed limit 5 miles an hour. Define your variable. Okay, so what they're asking me for, the speeds I'm allowed to drive. Okay, so X, the allowable speed in the parking lot. I can drive 5 miles an hour. I can drive 4. I can drive 3. I can drive anything smaller than 5. So X is less than or equal to 5 because I could do 5. Can't do 6. Can't do 10. But I can do less than or equal to 5. Those are the allowable speeds. I need at least 300 signatures. So I could get 300. I could get 350. I could get 500. I just can't get less than 300. So I need at least. I need greater than or equal to 300. Man. And number 3. The auditorium holds 500 people. So if P is the number of people, well, that number of people has to be less than or equal to 500. I can't do more than 500. I don't hold more than 500. I could do one person. I could do no people as long as I'm less than 500. I could be exactly 500. So it's less than or equal to 500. All right. Looking for a great job here in Chapter 3. Let's get off to a good start. Chapter 3. If you need to rewatch. Ask questions. Section 3.1. All right. I'll see you next time. Peace.